கேக்குதுங்களா? ஹலோ. Hey guys, sorry for the late. So, so today we'll solve this problem, which is word break. So basically, I'm going from top 100 questions. So actually, I was trying to pick a random one, but here I think leetcode picks from all the problems, not from this specific set. I think so. Whatever the filters we apply, that it will not take. So which is bad. Okay, which is fine. Let me see. It takes that list ID. Okay, I think it's not taking that list ID. Okay, I think it's not taking the list ID. Okay, let's not waste more time. Yeah, so let's focus on this one. So so basically here we will see what is given. So here it says given a string yes, and a dictionary of strings word date. Okay, return true if yes can be segmented into space separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay, you given a string and a dictionary of strings. Okay, you have a dictionary. Return true if yes can be segmented into space separated sequence of one or more dictionary words. Okay, so that means lead space code. So which is present. So and coming to here, apple and apple. So just apple and then pen and then apple. Okay, and similar to cats and dog. Okay, which is cats. Um, you have you have cats and then okay. I think here one thing which is not clear is so can it so is it are they are they I mean should they be mutually exclusive? That means there should be no overlap or it can be overlap. So that is one thing that I did not understand here. So basically so what I follow is so let's write down here. So uh, given string yes and dictionary of words and so we need to find so return whether yes can be split into two dict words. Right, so this is what we are asked to find. So but here so one thing that is not clear is so whether overlapping is allowed or not. So we will see by the example. So here what is the example that given? Let's see, somebody is messaging something. Okay, fine. So here s equal to cats and dog. Oh, so so not that way. No, cats. That's fine. And then and then you have sand. Okay, you have cat. You have sand, and you have dog, and you have end also, and you have cat. Okay, but it is false. Okay, then true because can be submitted. Okay, note that you are allowed to reuse a dictionary word. Okay, so you can reuse, but here the problem is, so that means, so you can reuse a dictionary word. Okay, so I think I'm going away from the problem. So let's read the problem once again. Given a string yes and dictionary of strings what did return true if yes can be segmented into a space generated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times. Okay, so that means so let's say if I segmented this into, so let's say if I segmented this into multiple strings. Okay, so given cats and dog, so let's say, so how many, so if I segmented this, let's say I have taken cats first. Okay, so the remaining word is and a and d o g. Okay, right. So let's say I have segmented and let's say you have og, so which is this is wrong. I mean, so this does not exist. Og does not exist. So you backtrack. Okay, so that means I actually backtrack, and then oh, and then I take cat, and then after that I take sand, and then I take og. So which is again does not exist. So I backtrack here. Mm, so and here um, instead of cat I can take sand, but I cannot take end. So earlier what we have taken, we have taken cats and we have taken end. Okay, okay, so that's why this is not splittable. I mean, this is not uh, this cannot be broken into a dictionary, maybe. So because we tried at cat and then we tried at sand, and og does not exist. But now instead of cats, now we tried at cat, and then we have sand. But here if we have san, only san in the dictionary, the dog is a separate word, and this is true. So so for me this seems like a backtracking problem, that you need to backtrack and try out all the possible combinations. So when we see problems like this, so we can think of backtracking. I think there is some lag. Right. So So this is kind of a backtracking problem. So that means so now that means I have to write the recurrence. So how I'll take that. Okay. So in the string, in the given string. Okay, now I'm thinking about the approach in the sense. So how should I go about it? So now when you have cats and dog given like this, so we check whether C exists or not, and then CA. If it exists, then you go again from the next, and then from here you try out the different combinations. So I need to think about the approach. So at each I, so let's write this. So at each, say consider this as I. At each I, I need to consider. So I will be moving, and then I need to consider 0 to I. I mean, so whether this string is present here or not. So then I take it or not take it. So that means whether you take it or you not take it. So no, you must take it, but you need to find with that combination. So that means when I is here, you take cat, and then there will be one more call from I to n, and then you stop it somewhere similar to I. You stop at j, and then stop at j, and then k to n you try, and when it does not work, you need to backtrack. So you need to backtrack from that, and then j you need to move forward, and then you try another combination. So here we just need to go through different combinations of each cut. We just need to find different combinations of each cut. So instead of finding each combination of cut, so at some at some I time, we know that it is part of a word. From that, I think so. I'm just thinking if we can use dynamic programming. That means reusing the previously computed values. So that means to compute solution at I, we can use solution at I minus 1. No, the because the sub problems are not overlapping. So this is one different sub problem. This is one different sub problem. This is one different sub problem. So they are not overlapping. Overlapping. So okay. Actually, I was asked a similar problem in shade chart interview. So there it is similar, but I need to print the different permutations of the string separated by space. So that I could not solve it. So because I think I'm weak in this backtracking or permutation problem. So I need to practice more on this side. So I'm just thinking how we can write the recurrence for it. So each at each, so we'll have a loop. So basically that means we have, and then we, so whenever we find a specific string, so we can say, no, wait on. So one, I think I got one thing here. So when we make multiple cuts, okay. So let's say you have lead code, right? So and it is lead and code tab in a dictionary. So you make a cut here, and the answer is, so here t of n equal to, so here t of 0 to I and t of I plus 1 to n. I mean, in the sense, so this should be true and this should be true. Okay, but if this is fine. So, but what if you have more than two cuts? So, so let's say you have k number of cuts. Okay. So, for each, so the solution is, so t of some 0 to I and t of I plus 1 to j and so on, t of some k plus 1 to n. So these are k cuts, right? So this is what we wanted, and this I, again this I can be extended. So that means now it is 0 to I, and then it can change, right? So I think I'm making some progress here. So likewise for each of, so for each of I, we need to move I, and then we need to find different combinations. Um, so 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 the overall solution would be, and then so this is at specific I, right? So and then you can have this number of I. So this is at one specific I, but you can have So you can have this I varying, right? So now you're taking it 0 to I, but later you can, I mean, so in the next iteration you can go from I plus 1 to j and so on. So then the overall solution will be, will be, so when you have 0 to I and t of I plus 1 to j and so on till t of k to n. So when you have this k parts, or so the total solution will be like this. So it's or t of 0 to I plus 1 and t of I plus 2 to j or j plus 1, so on t of maybe k minus 1 to n, so you will know, and so on, all the different combinations. So the overall solution is this. So this is the overall solution. So I think actually my Apple Pencil battery is very low. So I'll be back, guys. Hey guys, I'm back. So, okay, so let's see. So whether I can solve this or not. But as in the as I got in the comments, so I think someone pinged me, sites and told that. So why can't we just check? I mean, just iterate through words if it is present in the string or not, or substring or not. Okay, yeah. So he actually says, I mean, so maybe I think his point is so we'll check cats if it is there, then we iterate through others. I mean, through other. I mean, except this. I mean, we'll iterate through the dictionary again, and then so let's say we have taken cats, and then we'll see after cats we see if and is present, yeah, it's present, and then OG is present, no. So yeah, I mean that is also another, but similarly, I mean similar to this, we have to do the same process, but there. So if the dictionary is very long, so let's say if the string that you have given is let's say like 10 characters, so which is let's say let's you call it as n, but the words you have given is very huge, let's say. So iterating through all those words is not good, right? Yeah, so let's concentrate here. So basically here what I'm saying is, so the equation that I wrote is basically at each I, at each I you make a cut. So similar to lead code. So I make a cut here, one cut only. So that actually produce. I mean, produce this string. I mean, produce the words in the dictionaries, which is true. But similarly, let's say you need to make k number of cuts, right? So like at I, and then from I plus one to it's j. I mean, at j one cut, and then it's k one cut, and so on. Let's say you have k cuts. So the and I mean, so the t of 0 comma I basically just checks whether this particular substring. Oh man. Yeah. So t of 0 comma I just checks whether that particular substring is present in the dictionary or not. So similarly, this, right? So the result is end. I mean the end of all those k cuts. So if all are present, then only you say the particular combination is valid, right? Uh, so and similarly, so similar to this, you need to check different combinations. In the sense, how you made these number of cuts at I. So you need to make number of cuts at I plus one, I plus two, and then and so on. So and in this case, the equation will be uh, or. So that means, so either of one combination of permutation is true. So we can say that is a valid solution, right? So using this intuition, so can we see, so we can see if we can form, or if we can write some code, or some pseudo code. um, so okay, I'm just thinking. Okay, so basically for this, can I write a recursive? So for this part, can I write a recursive code? So that means at I. So that means here I is going from. Mhm. So isn't it like we need. So you have one loop. So let's say, I mean, I don't know if this is right or wrong. So you have one loop. So basically, that actually assumes that I, and then it goes from I plus one to another j, and then j plus 1 2 and so on like that. You there you actually make different cuts. Mhm. And in the outer loop, so in the outer loop, no, I think okay, so I think I'm confusing here. So when you make a cut at I, so when you make a cut at I, and then you make another cut at J, so and then you make another cut at K, um, so that means let's say you have for I in range of 0 to n. Okay, so you actually check so whether 0 to I is present in dictionary. So if it is present, so that means you make a cut there, right? So now you need to again you make a cut there, and then from that I you need to take one more cut. So that means you recursively call t of whatever the function this is. So you do I plus 1 to n, you call this. So let's say you have result equal to true, and so here let's say now the result will become result and t of I plus 1 comma n. So this is so this is this part, right? So I mean making different cuts, is it? Uh-huh. So oh wait on. So but if I varies, so then it will become I plus 1, right? So I varies and then it will become I plus 1. So and then we check, so 0 to I plus 1, if there is already anything present. Okay, but what about this part? So I think I'm confused here. So okay, so at I you make one cut, at J you make one cut, at K you make one cut, and then so if that doesn't make sense, I mean if that doesn't form a solution, you need to again try another combination. That is, so how do you make another combination? You move I. Mhm. So we'll stop the streaming at 8:10 because I have a meeting at 8:15. But meanwhile, let's try solving it. I think I'm having some discrepancy in thoughts, so I'm not able to connect the dots. So somewhere I'm not able to connect the dots. Okay, I think here. So basically, let's say this is a function. Okay, some t, and it receives, let's say, start and end. Okay, and we will, so this will be from start to end plus 1. So here, so if s of start, no, so it will be from start to end, and you check start to I or I plus 1. So I will become, right, so that means to I. Start to I or I plus 1. So let's say I plus 1. Okay. So result will be result and P of I plus 1 to n. So I plus 1 to n. Right? So let's say we have another. So let's say we have another loop. I mean another loop. So which actually goes from 0 comma n. So n is length of s. Okay. So let's say result equal to false initially. Okay. I think here I'm trying to make some progress, because this I'm gonna send it in place of start. So let's say result equal to result of t of I comma n is n minus 1. So and then you return result. So let's see how, let's do a dry run. Okay. So how many minutes we are like 8. Okay. I think okay, fine. So basically, let's do a dry run. So given s, so it will be run from I in range of 0 to n. Okay. So this I is nothing but the cuts, right? So I mean, at each cut, how do you make each cut, right? So let's say we make one cut at I. So here it will come here. It checks. It checks. I'm still. So here the problem is. So let's say you have lead code, right? So at 0 at L, let's say it goes from 0 to n minus 1. So let's say initially it went to 0. Okay. So and then it comes here. So again I start from 0 to n minus 1, and then you check um, 0 to 0. So you check L. So if L is present, no. Um, and then G, you check E is present, no. I mean LE, no. LE, no. LET, lead, yes, it is present. So then you go from here. Okay. Okay, this is okay, but okay. So here we will. So if it is there, then fine. If not, we will just so from start to n plus 1, we will just iterate from start to I plus 1, I mean to end. So basically what we are doing is from start to end, we are just so let's given this, so given this lead code example, so from the start given to end, we are just getting each substring like COD, CODE, and then checking it. Okay, that is okay. So what if this doesn't, if it is not present? I mean, let's say CODE but does not exist in the dictionary. In that case, um, it comes and it return result which is wrong. So in this case, we'll return result as true. Yeah, I think somewhere, I think I need to rethink. So making k cuts. So to make k cuts, we are using this, isn't it? So the only problem is when this is when this is not does not exist. So how do we know that this does not exist? I mean, so given for a function, so with start and end. So how do we know it does not exist? So if you put result equal to false here, then fine. So we need to put all here. I mean, if you put false, making end does not make sense because in the end it will always be false. Mhm. So the only problem here is how do we know if a I mean if this is not present in the dictionary. So how do we know? Because here by default we are making result equal to true. Mm, okay, guys, I think this is a little tricky for me. So I'm stopping stream now because I have a meeting now. So we'll see. I'll come back and we'll definitely solve this. So my motto is I don't want to see the solution. No, I don't want to. So I want to solve it on my own. So without seeing the solution. So let's see the different solutions and I'll come back.